Hello guys, welcome to our class for today. This is No My Science Tutors Online, and I hope you are doing good and great. For our class for today, we are going to be looking at conduction through gases. Conduction through gases, and under it we'll look at the gas discharge tube or cathode rays. Then we'll also look at conditions under which gases conduct electricity, and then application of gas discharge tube. We'll look at hot cathode ray and thermionic emission, then the diode valve and the cathode ray oscilloscope. So that is the area that we want to cover in this particular topic. Alright guys, so if you have your writing materials ready, we'll go to the class. But before then, please, if you are just visiting this channel, subscribe to our channel, click on the notification bell so that when we upload a new video, YouTube will notify you. Also give us a like, give us a thumbs up. If you are a returning subscriber, you are welcome to this physics class, and we hope that you are benefiting from all the lectures that we have posted so far. Alright, so gradually we are moving on and we are covering the senior secondary school classes physics curriculum. Okay, so having that said, please, if you are ready, let's go straight to our class. So as I said, we are looking at conduction through gases and then conduction of electricity through gases. All right, and we'll be looking at the electric discharge tube, the gas discharge tube. Normally gases don't conduct electricity except when they are within the gas discharge tube or cathode ray. Okay, so the gas discharge tube, this is a picture. What you are seeing on the screen is a picture of the gas discharge tube, and the gas discharge tube is actually used to study conduction of electricity through gases. And what does it contain? It contains a long glass tube with metal plates of electrodes sealed to each end of the tube. So this is an electrode and this is an electrode. Then you have a vacuum pump that is connected to the glass tube. Now the vacuum pump is used to regulate the pressure of gas inside the tube. Alright, so this is what it actually contains, the gas discharge tube. It is easy for you to draw it. Then it can be connected to a voltage source. Alright, can be connected to a voltage source. So if you look at the tube and the metal plate that are on it, you find out that the positive plate is opposite to the negative plate, and the positive plate is the anode, the negative plate is the cathode. Right, so there is air within this tube that is regulated by this vacuum pump. All right, so this is the gas discharge tube that is used to study conduction of electricity through gases. Now, under which condition does gases conduct electricity? Gases will conduct electricity under very low pressure of about minus 0.01 millimeter mercury and at very high potential of greater than 1000 volts. Alright, so those are the conditions under which gases conduct electricity. So how does this happen? Don't forget that conduction of electricity has to do with movement of ions within the fluid. Okay, when there is movement of ions or electrons within the fluid, you have an electric current. So how does gases conduct electricity in this particular tube? Alright, so at very low pressure and high potential difference, the gases in the tube breaks into ions. Alright, the gases in this tube breaks into ions. The positive ions will move to the cathode, while the negative ions and free electrons, they will move to the anodes. Now the positive ions that move to the cathode, they will knock off electrons from the metal plate, that is from the surface of the metal plate of the cathode, and those free electrons, they will now start to drift like ionic stream or electron stream to the anode. This drift of electrons to the anode shows that there is electricity, or that current is flowing in the system. So this is what the diagram this is what the diagram is representing, and these are the electrons, stream of electrons that have been knocked off from the surface of the cathode, and they are moving towards the anode. I hope you can see that. Okay, so this is how the discharge tube works, and this is how it is used to study conduction of electricity through gases. Okay, so what are some of the properties of cathode rays? So these ions, or these electrons that are knocked off from the cathode, they are known as cathode rays. They are known as cathode rays. Okay, they are known as cathode rays. So what are some of the properties of cathode rays? Properties of cathode rays. 1. They consist of streams of fast-moving negative electrons. Because they are negatively charged, they are attracted to the anode. That we have just discussed now. They cause glass and other materials to fluoresce or glow. That is, if you look at your fluorescent tube is an example of a gas discharge tube. So they causes glass and other materials to fluoresce or glow. They are deflected by electric and magnetic fields, and they travel in a straight line. They can ionize a gas. They will turn a light paddle wheel in the tube, showing that they have momentum and therefore mass and energy. They produce intense heat on objects which stops them. They can affect photographic plates. They are highly penetrating and can penetrate through metals such as aluminum plate, steel plate, and gold foil. They can produce X-rays. So these are some of the properties of cathode rays, and you need to take note of them. Okay, now how or in what instances are cathode rays applied? Application of cathode rays. So cathode rays, as I mentioned before, they are applied in fluorescent lamps and neon lamps, neon signs. So if you travel along the highway, especially at night, you will see some signs that has different coloration, very beautiful coloration. Those are neon signs. So gas discharge tubes or cathode rays, they are applied in fluorescence and neon signs. So one of the application of cathode rays in fluorescent tubes used commercially for lighting and display signs. The tube contains mercury or sodium vapor, which glows at very low pressure at the passage of cathode rays. Don't forget, as we said before, that gases will conduct electricity under low pressure and high potential difference. So the interior of the fluorescent tube is coated with phosphorus, which gives off visible light when hit by ultraviolet rays. The color that we produce by a fluorescent tube depend on the nature of the gas in the tube. So if you want to have different colors of fluorescent tube, you have to use different gases in the tube. Then the nature of the coating in the tube. So as I've said before, fluorescent tubes are used as display signs, and they are more efficient than filament lamps. Neon gases are mostly used in the tubes, which always produce an orange or red color. So these are some of the applications of gas discharge tube and cathode rays. All right. So now we'll also look at other types of cathode rays. right? We'll look at other types of cathode rays. And in this instance, we're looking at hot cathode rays. Hot cathode rays. And the phenomenon is known as thermionic emission. Thermionic emission. So a hot cathode is another way of producing free electrons, right? So the picture here shows a sketch diagram of of a hot cathode that can be used to produce free electrons. So whenever a metal is heated to a sufficiently high temperature, electrons are emitted from the metal surface, and that is what thermionic emission is all about. Thermionic emission is the emission of electrons from the surface of a hot metal. Alright, so that is thermionic emission. Emission of electrons from the surface of a hot metal is known as thermionic emission. And how does this happen? How does this happen? Okay, so you see the setup here. This is your cathode, alright, and this is the surface of the cathode, the hot filament of the cathode. Then there's a plate here that is labeled plate A, that is the anode. Don't forget the cathode is the negative terminal and the anode is positive terminal. Then you have a galvanometer here or a milliammeter. Okay, then this is just a diagram of streams of electrons. This is the glass tube, okay, where the electrons are produced. Then you have a vacuum, just like you had in that gas tube that has a vacuum pump. So you have a vacuum pump here. Okay, vacuum. All right, so when the tungsten filament is heated to a high temperature, the extra energy is given to its free electrons at the surface of the metal. So when this tungsten filament is heated, electrons are emitted from the surface. Now, the extra energy is given to to the free electrons at the surface of this metal, which enable them to break out. They break out from the surface of the metal, and they now exist as electron cloud. They exist as electron cloud within this space. These electron clouds are now attracted to this positive anode. Okay, so this is the process of thermionic emission. The emitting filament is the hot cathode, that is the surface, that is the emitting filament. So when this plate that is here is made positive with respect to the cathode, the electrons will be attracted to the plate. But if it is made negative, the electrons will be repelled. No matter how hot the filament is, the electron will be repelled, because if this is negative and this is negative, they are now like poles, so there will be repulsion. Okay, so this is just how thermionic emission occurs. So other devices that operate on the principle of thermionic emission are called thermionic devices. An example are one, the diode valve, S-ray tube, and cathode ray tube. These are devices that operate with the principle of thermionic emission. Alright, so please take note of this and know what is thermionic emission. So we will look at some of these devices, and that is the diode valve. So the diode valve basically is a device that allows current to flow in one direction. Okay, so because it allows current to flow in one direction, it is used as a rectifier. Okay, so this is just a diagram of the diode valve, and if you can look at it, it is almost like the diagram we drew for thermionic emission, right? So this is the hot filament, the cathode, then you have the plate, this is the anode, then you have the glass envelope or the glass tube. So the diode valve consists of a cylinder, a hot filament, It's made of tungsten, which is the cathode, and then it has the anode. Okay, it has the anode. So when this diode is when this piece of device is placed into operation, it has a characteristic curve, and from studies the characteristic curve shows that it does not obey Ohm's law, and hence the diode valve is not an ohmic conductor, and it can be used as a rectifier to produce a DC voltage from an AC supply source. Okay, so because the diode valve allows current to flow in only one direction, it can be used as a rectifier. So it can be used to produce direct voltage from an AC supply source. Alright, so that is one of the instruments that uses the principle of thermionic emission. So now we are going to be looking at the similarities and differences between thermionic emission and liquid vaporization. But before then, I think we still need to look at another instrument that uses the principle of thermionic emission. That is the cathode ray oscilloscope. The cathode ray oscilloscope. You see this instrument mostly when you go to the hospital. Okay, so they use it to measure different waveforms, especially alternating waveforms, or in electronics devices they use it to measure the flow of different waveforms. So but mostly if you want to see this instrument at work, if you go to the hospital, that is what they plug around the bedside of patient that gives different waveforms. Okay, so that instrument is an example of a cathode ray oscilloscope. Alright, so this is a picture of a cathode ray oscilloscope, and if you look at it, it has one end that is called the electron gun. It has in the middle deflection system, then it has at the other end the fluorescence screen. So these are the three regions of the cathode ray oscilloscope. The cathode ray oscilloscope uses the principle of thermionic emission like the diode valve. Alright, so the oscilloscope consists of a vacuum tube containing an electron gun at one end and a fluorescent screen at the other end. Then in between are two pairs of deflectors near the middle of the tube, and that is exactly what I've said before. These are the two deflectors. Deflectors are the S plate and the Y plate. Then you have the electron gun that contains the cathode. Okay, it contains the cathode. Then it has the anode that are close to it. Then this is a control grid. Alright, so all these components of the electron gun, they have different functions as the electrons are produced from the cathode. So the electron gun consists of the heated filament to supply electrons by thermionic emission. You already know what is thermionic emission. Okay. Then the cathode and the anode made more positive with respect to the cathode so as to attract the electrons emitted from the cathode. The anode also acts as a focusing lens to accelerate and focus the electrons onto a spot on the fluorescent screen. You have the deflectors X and Y. They are arranged in pairs to control the path of the electron beam. The Y plate deflects the beam vertically, while the S plate deflects the beam horizontally. So such deflection occurs when an alternating potential difference is applied across the plates. So this is how the cathode ray oscilloscope works. The device is used to study all types of waveform, especially the alternating current waveform. Also, it is used to measure frequencies and the amplitude of voltage of electronic devices. So this is the cathode ray oscilloscope, and this is how it works. It uses the principle of thermionic emission. So we've mentioned two devices that use the principle of thermionic emission: the diode valve and the diode valve and the cathode ray oscilloscope. All right. So similarities and differences between the thermionic emission and liquid vaporization. Similarities: in the two instances, heat is involved in both processes. Both occurs at the surface of the materials. Liquid evaporation occurs at the surface of the liquid, while thermionic emission occurs at the surface of the metal, of a heated metal. The rate of the phenomenon increases with temperature. Yeah, evaporation increases with temperature. The same thing with thermionic emission. Particles are released in both cases. Liquid particles, which comes out as vapor, and then for thermionic emission, you have electrons that are released. Then the differences: thermionic emission takes place at the metal surface, while evaporation takes place at liquid surface. Electrons are released in thermionic emission, while water molecules are released during vaporization. Thermionic emission occurs at different temperatures, while evaporation occurs at all temperatures. These are the differences between the two. So I just brought this up so that you have a summary information that you need to know. And as you are preparing for examinations, please, these points are very, very important and key. Okay, so guys, thank you so much. This is where we are stopping for this particular class. We have been able to cover this topic, and then go to your textbook and do more reviews. Okay, so thanks a lot. But before I go, please, if you like what we're doing, give us a thumbs up, give us a like, give us a positive comment. Also, subscribe to the channel if you are just visited this channel. Click on the notification bell so that when we upload a new video, YouTube will notify you. You can reach us through the WhatsApp number that is showing right on your screen, and also through the link. There's a WhatsApp link that is showing under the video. You can click on that link. It will take you to our WhatsApp chat group. Okay, so thank you. This is your online video class. We appreciate you for staying with us and for visiting our channel. Please invite your friends to come and enjoy what you are enjoying. I remain Otobo Michael, and I'm your online tutor. Thank you, and see you in our next class. Have a nice day.